Our love's like the stars in the sky. If you look, you might find it tonight.
Okay, hello everybody, and welcome to the final session of this great day of talks. If it has a theme, I was thinking potentially we're talking about new arrivals, new mechanisms. So see if you agree with me as the session continues. So for our first talk, I'm delighted to welcome Martin Jones from the Francis Crick Institute, and he's going to tell us all about a new arrival to the CCP family. Over to you.
Thanks very much. Thanks for the opportunity to tell you about our new collaborative computational project. So I'm an outsider. I'm not a cryo-EM person, so hopefully you'll come along with me on this journey, and hopefully we can find ways to collaborate across the domains. Okay, so not working. There we go. So why volume EM? I think we all know why this is. Normal EM, so not cryo-EM, but scanning EM, transmission EM. We're always looking at 2D projections or slices, so we don't really get any 3D information. And if you're only looking at 2D information, you might misinterpret the scene. So you really need to get a good sense of the whole 3D scene. And actually we had Prince William came to the Crick earlier in the year, and they wouldn't let me put these slides up while he was there for some reason. I'm not sure why. Actually, we got him to do some ultramicrotomy, which I think was quite an achievement. Okay, so the types of volume EM methods that I'm going to talk about, there's a whole range. One example is this serial block face scanning EM. So it's a regular SEM, and then we have the diamond knife inside the chamber, cleaves away some usually tens of nanometers off the surface, and we build up the whole volume destructively going through the sample this way. There's lots of different methods. Generally, when we talk about volume EM, we say it's through depths of at least 1 micron, but this is, open to interpretation. There's a whole load of different ways we can do that. So transmission EM based methods like serial section, TEM or serial section tomography, grid tape TEM, FibSem we've heard a lot about in various contexts already in the last day or two, and these array tomography methods as well. And the sort of data we get are these really nice, very sort of hypnotic data set. So on the left is a serial block face data set going 50 nanometers per slice through a pellet of HeLa cells. That's a few hundreds of gigabytes for an overnight acquisition. On the right is a FibSem data set. So that's 5 nanometer isotropic going through an individual HeLa cell. That's about a terabyte of data. It takes some days to image, so much slower but much higher resolution. And this kind of family of techniques was one of Nature's 7 methods to watch in 2023. And just in the last year, the sort of connectomics version of this has also been cited as such as well. So the reason I'm here specifically is, so maybe historically, cryo-EM and volume-EM have existed as different things. The domains are expanding and they're starting to overlap a lot more. And there's things in the middle, which we both talk about in our individual domains. And if people aren't collaborating when they're doing the same thing, somebody somewhere is duplicating work or reinventing the wheel. So I'm very keen that everybody knows what everybody's doing, and we try to benefit from each other's work over the past years. And actually, CCPs are the ideal platform for doing this. So the fact that they're all centralized at COSEC, and we have COSEC members working across different CCPs and on similar infrastructure means that the messages for these new technology developments pass very quickly through the communities. So CCP-volumeEM specifically is a 2-year funded project. So we've got until the end of this year. It was kind of a project to scope out new CCPs with a view to creating a long-term CCP. And yeah, we have this benefit that we're integrated with COSEC to join the dots. We have access to knowledge that's been gained in lots of different CCPs. We have a very strong overlap with CCP-EM, so a lot of our core members sit in both camps. And the things we're kind of dealing with, the current situation is all of these different methods, they all have slightly different analysis, reconstruction, processing techniques. There's really no consensus on anything about what's the best tool to use for any of these things. So there's lots of reinventing the wheel, lots of diluted efforts. The tools are often quite not so user-friendly, let's say. So it's quite a high entry barrier. So people maybe aren't even getting the benefit of the new developments that are becoming available. And there's very few good ways to learn how to use these things, as the training pathway is not well established. So for CCP-volumeEM, we've established in this initial phase to work on 3 different work packages. So look at the community building and consolidation, research software and data management, and training and skills as the 3 main pillars. So starting on community building. So there are a lot of communities out there already. We're not proposing to reinvent the wheel here either. We benefit a lot from all of these different communities, from CCP-EM through to Bioimaging UK, Image.sc forum, and lots of things that have gone before. So we're really making sure that we leverage all of this as well as we can. One of the main ones that I want to mention is the volume-EM community initiative. So this started in 2019, I think. Is that right, Michelle? Yeah. And there's a nice website here, volumeem.org, has a series of working groups for sample prep, training, industry partners, community and outreach, and data. So you can sort of view CCP-volumeEM as having been born out of this sort of collective. Another community I want to mention, which I think might be of increasing use here, is that there's a Slack workspace called EM of Cells, Tissues and Organisms. It's community driven. It's currently sponsored by JL with support from King's College London and the VEM Community Initiative as well. It's very active, lots of interesting discussions about all sorts of things. There's a QR code there for the join link, so you can sign up to the workspace there. And so I had a quick look on it earlier about mentions of cryo-EM, and I found this. So Laura posted this. It is in fact a hat that she thought looked a bit like a cryo-EM reconstruction. There are other actual cryo-EM things on there, but that was the first one I found for some reason. So maybe everyone wants to buy this hat for next year. And then for our own community, we've set up a website. So this is where we post a lot of our information now. This is QR code and link for the website. And there's various other attached things like Blue Sky and LinkedIn and YouTube and so on. So I'll pop this slide up again at the end for if people want to go and have a look. The kind of things we've been doing for the community or to help build the community. In November last year, we had our first meeting and had about 80 attendees, so 40 in person, 40 online at the Crick. It's very interesting. Most people in our community don't really know what CCPs are, so it's very interesting to see what CCPs do and what we can, what benefit the community can get from it. There's a write-up of this on the website, and we're looking at things like drafting out a roadmap for the coming years of the activities. All of the content from these sessions we're trying to put onto our YouTube channel. So, for example, Shaw's gave a talk, about 20-minute talk about CCP-EM. It's very interesting. If you want to see the history and the roadmaps of that, it's very interesting. 46 years of CCP4 was a bit mind-blowing. So we have to keep remembering that we're right at the start of a journey that other people have been doing for many decades. Okay, so community building, ongoing activities centered largely around our website and things advertised there. For the software and data management, like I say, there's a lot of different things that we might need to do in our processing. A couple of the common things we do are we acquire data in tiles and stacks. And so even the first step of stitching things together, stacking things, aligning them is challenging. And for end users, again, there's in our team of 12 or 14 people doing this, there's probably 8 different ways that people do this. So it's really no consensus. General process, taking a bunch of image tiles, stitching them, aligning them, and preparing them to then go on and do our processing. Sorts of processing we commonly do. We've seen a couple of really nice examples earlier in the context of in situ, are the things like segmentation. We're starting to increasingly use these AI-based methods. So here's data scrolling through a pellet of HeLa cells. The magenta lines are deep learning predicted nuclear envelopes. The community uses quite a lot of different AI models. I'd say the Connectomics and volumeEM community is one of the early adopters for this sort of method, and I think are doing pretty well with it. But it's still very challenging for end users to really get the most out of this, as we saw before. That, you know, getting this into the hands of the right users is tough. And we want to get to these kinds of things so we can get to 3D renderings where we can start to quantify things. So the nuclei on the right were predicted via a UNet system. The mitochondria on the left were predicted using a Panoptic Deep Lab in a plugin called Empanada in Nepari. And a lot of these things are, I think, the infrastructure them and work with them in different viewers. So this particular one is called Mobi. It's a plugin we use a lot for our multimodal data visualization and project management. And this ability to go from millimeters down to nanometers really is only possible for us for these next-gen file formats. And one of the things it lets you do, again, it came up earlier in some of the smart microscopy discussions, is you want to be doing as little of the hard stuff as possible. So get as much information upstream from easier or lower resolution imaging methods to really target what you're doing, and having this sort of ability to map data sets together is super useful for that. So that's visualization is, I think, a largely solved problem for next-gen file formats. Analysis is maybe less so, so how to analyze these data sets across these new file formats is ongoing work. And one of the activities we're doing in CCP-volumeEM is to develop new ways to leverage these file formats and to help the community learn to do it and develop their own systems to do it as well. And we're doing this by creating benchmarked exemplar workflows demonstrated on publicly available data. So this is a big multi-beam SEM array tomography data set that is on Empire, and then using existing Python libraries, so Dask and Multiview Stitcher. Then Yoast has been working on fully automating this process. So many thousands of individual tiles of array tomography, which are all flexed and some folded, and very challenging projects. Doing this in an end-to-end way is very hard, and there's very few solutions that work across a range of data. So we're aiming to get this to be as broadly useful as possible. This is available at the moment, kind of work in progress still, but NuVis Align is a GitHub repo that Yoast in the team has been working on with Marvin Albert from Zurich. Another activity that's been going on is we don't necessarily think we need to invent lots of new software, but there's a lot of really nice software out there already that, for whatever reason, doesn't have the funding or the developer resource to be able to really push it forward to adopt new technologies very quickly. So we've been working, Mariam in COSEC has been working with us to enable a really nice deep learning plugin called Empanada to, first of all, update it to recent Python. So it got a couple of years old and suddenly stopped working with modern software stack, and now enabling it to use next generation file formats as standard. And actually, we hope that solving this problem in a couple of common use cases means that we'll have the blueprint to be able to do that in other tools and be able to advise other community members how to do so for their tools. Okay. Then on to the training and skills part. So for training, as a work with the volumeEM initiative, we look to run courses on STFC's data analytics as a service platform, which I think is called ADA now. And we've been working with the team to deploy courses on this, both in person and online. So Michelle's team at RFI have built a load of containers for common volumeEM software analysis packages that we can run on these virtual machines, or we can run on people's local HPC. For example, we ran a course on a plugin called ClemReg, which we use for automatically aligning correlative light and EM data sets. There's another aspect of training which I think is very underserved in the community, which is kind of intermediate, like people who are prospective developers, maybe people who know their way around a little bit of image analysis, but they want to go the next step and be able to write their own plugins or their own scripts to do their analysis. And there's very little training for that around at the moment. And this is a really important group to target, because that's maybe the group that's most likely to go away and start reinventing the wheel. So if we can share best practice and knowledge as widely as we can in that community, then hopefully that will propagate through the rest of the community. And we've got a few different approaches for doing this. So again, on our GitHub organization, we have some guides that the team have been building. So there's one, if you want to learn more about next generation file formats, there's a guide for this. Again, there are very good resources out there. We don't feel the need to rewrite everything that's out there. We link out to existing resources where it makes sense. More generally, software development, so things like how to use version control, how to do testing, containerization, how to write documentation. All these things are skills which people need to be taught, and we're hoping to be able to support that kind of learning as well. Another output that we've started in the last few months is a series of show and tell webinars. So it's once a month. We've had 3 now. So we had an introduction to containers, good practice for software, for image analysis software development. And just in the last week, we had introduction to Jupyter Notebooks with Piper from Michelle's team, or Michelle and Mark's team, I think. And we have one coming up on next generation file formats on May the 19th, I think is confirmed. It might shift slightly. The details will be confirmed on our website and the mailing list. We also use very common model of doing hackathons. So we had one in March on next generation file formats. And we had a mix of developers, next gen file format experts. You can probably recognize at least a couple of CCP-EM faces in there as well. And we really wanted to make sure that we, again, we don't run off in a random direction. We work with people who are already working on these things. We work with people who are going to be the end users of these things, making sure everyone's involved in making this as useful as possible. Otherwise, it will become just another thing that nobody really uses. The mechanism for getting involved in this, I was talking to Mark earlier, there's a very transparent and open method for getting involved. If you want to discuss whether this is something that's useful in your work, the development of the standards in the OMEs are on their GitHub repo as a series of requests for comments, and they're really driven by use cases. So if anyone's got a use case that they think might benefit from a next-gen file format type input, then please have a look and see if you can add a user story. So as in our hackathon, we had we helped some of the users write a user story for a specific use case that they had in mind. Yeah, so if this might be useful for CryoEM or CryoET, then do try and think of user stories or come and speak to me and I can help you try to input useful information into this process. Okay, so a few upcoming events. So we have on our show and tell series, so the next gen file format one, I think is confirmed for 19th of May, 12:30. We have a few others that we're negotiating the final details of, likely one on segmentation, potentially one on large scale deployment of segmentation via workflow orchestration methods. We are very interested in suggestions. So if you think of something that would be useful for us to present, or you want to volunteer to present something, please do get in touch. There will be a couple of online courses coming up. We're just pinning down the dates for this. So there'll be an introduction to Napari, which has been mentioned once or twice already, which we're increasingly using for our Python-based code bases. And then an introduction to this Empanada plugin, which I mentioned earlier for segmentation. We have an in-person image analysis for correlative light and electron microscopy course coming up at the Crick. So this will be a 5-day course. The QR code there for the website. At the moment, there's no registration link. It's just register your interest and we'll let you know when the registration becomes available. A couple of other related events, not specifically run by CCP-volumeEM. There's the VEM Technology Forum, which I believe Michelle would be the person to ask about if anyone wants to know more about this in Beijing later in the year. And then one that I'm involved a bit with is the Crick Bioimage Analysis Symposium, which will be in November. I think historically we've not had a lot of cryo-EM people come to speak at these types of conferences. I personally would like to see more. So if you are interested in getting involved with that, please do consider submitting something to that. Okay, I think I'm just about at the end of my time. So a few ideas, just random thoughts I had basically this morning about things that we might do to collaborate between CCP-EM and CCP-volumeEM. I think there's probably a few training events we could run collaboratively that would be of a huge benefit. I think hackathons in this middle ground could be very interesting. Testing and extension of existing code bases. So, you know, maybe we have a tool that doesn't quite fit for you. Maybe you let us know and we might be able to work with you to develop it towards a better use case for you and vice versa. I really like the idea of curated benchmark data sets, especially multimodal ones. And these can seed things like community challenges where people can, these are often the very rapid ways of advancing the cutting edge of these methods. So I really like the idea of doing that, and the bigger the community behind that, the better. And yeah, open for other suggestions. Feel free to tell me over a beer later. And then I'll just end again on our website. There's a whole list of people now who are involved, many of whom in this room. And I'll thank all of them for their sterling work in getting us this far. And thank you for your attention.